This is a good point. You need to come do test prep. Okay, so function composition. So getting into unit 9, the first thing in this, we're only learning one lesson today, function composition. So this reads f composed of g of x. That little O is just like saying the word compose. So a lot of times you'll hear it short notation, FOG of x, FOG. That's like an open circle, not a time sign, very different. So we can rewrite FOG of x as this, f of g of x. This is always how I rewrite it because then it's a lot more straightforward of what mathematically it's asking you to do. So watch, this is a trick I use to rewrite it in the correct format because when people see this, a lot of times they won't know which one is squished inside. So I just work backwards like this. I start here and squish backwards. So if I squish x back in with g, that's g of x. Squish it back in again, and that would be back into f. Does everybody see my little trick? Okay, awesome. Now let's look. If I said find f of 2, if I said find f of 2, what would you do? Plug 2 into x, replacing it. So you're saying take this 2 and replace it there. So that would be 2 squared minus 3. Does everybody agree? So what do you think? Anything different here? If we have a g of x, and just like our 2, shouldn't we take function g of x and replace it with x, just like we did with the 2? Yes, that would make sense. Math always works the same. So you're replacing that, so that would be 2x plus 1 instead of x, and then squared minus 3. Do you guys see how they look the same? It's just replacing it with the correct thing. Awesome. So then from there you could obviously simplify. This would be 4 minus 3, which came out to be 1. This one we would need to distribute out. 2x plus 1 times 2x plus 1 minus 3. And then we would distribute and combine like terms. So we would have 4x squared plus 2x plus 2x. So plus 4x plus 1 minus 3. So that's 4x squared plus 4x minus 2. And I've had people ask, do I need to factor that? Well, is standard form or factor form better? Neither. So why do extra work? That can be an answer, or factor form can be an answer. I'm not going to do extra work, though. Stop. Done. Easy, right? Okay, awesome. So let's do another one. So now we're asked to do GOF of x. Take x, squish it back in with f, that's f of x. Squish it back in again, so that's g of f of x. So now we're plugging f of x into g. So I'm going to find f of x. There it is. Plug it into function g wherever there's an x. So that replaces that. So we have 2 times x squared minus 3 plus 1. The x is not there anymore. It's replaced with function f. So then we would distribute. So that's 2x squared minus 6 plus 1. Do you agree? Which is 2x squared minus 5. That's our answer. Now look, FOF of x. So you'd say squish x back in with f of x, squish it back in again, f back into function f. So what I always do is rewrite it twice. So we have 2 f of x's. So now we're taking this and plugging it back in, right? So replacing it. So wouldn't that be this? X squared minus 3 squared minus 3. And then we wouldn't break forbidden rules, so we would have x squared minus 3 times x squared minus 3 minus 3. So then we'd have x to the 4th. Yep, so she's skipping ahead and doing minus 6x squared, and then plus 9 minus 3, so that would be x to the 4th minus 6x squared plus 6. Okay, how about you guys do GOG? GOG, go. Somebody said 4x plus 3? Do I need to go over it for anyone? Okay, awesome. Now watch, this one's actually easier. Let's do this the easy way. Watch what we could do. So this one says FOG of 2. Take 2, squish it in with g, that's g of 2. Squish it in again, f of g of 2. So now what we're going to do is just calculate g of 2 first. What would g of 2 be? Plug in a 2 into g, that would be 4 plus 1, wouldn't it be? So we're now just looking at f of 5. Does everybody understand what I just did? So now f of 5 would be 25 minus 3, which is 22. Our answer is 22. Let's do those ones the easy way. Okay, now the reason I'm showing you one more is because this is usually when people start making errors. When there's multiple x's, you have to plug it into. So watching this one, FOG of x, so you'd say x squishes back in with g of x, squish in again, f of g of x. So I'm going to locate g of x, there it is, plug it into function f. Now notice a lot of people will just plug it in there. That would not be correct. You got to replace all x's with that. So now we have 2x minus 1 squared plus 2, and then 2x minus 1. Does that make sense, everybody? Yeah. So then from there, distributing that out, we would have 4x squared. I don't suggest doing it in your head. Minus 2x, right? So minus 4x, and then plus 1. And then right here we would distribute this through, so that'd be plus 4x minus 2. So 4x squared, minus 4x plus 4x, and then minus 1. Okay, you guys do GOF of x, and then FOF of negative 1, and then we'll know for sure if you are good to move on or not. What'd you get for GOF of x?
2x squared plus 4x minus
2x squared plus 4x minus 1. Any questions on how they got that?
Nope.
Okay. Then FOF of negative 1. I'm just going to rewrite it though. F of negative 1. I got what? Negative 1 is correct. So you take negative 1, plug it into F. Negative 1 squared plus 2 times negative 1, so that's 1 minus 2, which is negative 1. Then you're going to find F of negative 1, which is the same thing we just did, right? So then you would get negative 1. Okay, awesome. Now let's move on to this is something you need to put in your notes. The words one-to-one. This will be on the final. I've been told that knowing what a one-to-one function is important. So everybody, to make something a function, isn't it true that each x can only have one y? That's what, by definition, what a function is. Each x only has one y. So let's look at this right here. Here's some ages. Here's the cholesterol level. Is any x pointing to two y's? No. No, each x only has one y, doesn't it?
Yeah.
So this would be considered a function. Now what makes something one-to-one is going backwards. Do all the y's only have one x? So everybody, do you see how this y has two x's? Yeah. It would be a function, it just would not be a one-to-one function. So it's just got to go both ways. Does that make sense?
So what is a one-to-one function?
So a one-to-one function means that the original and its inverse are both considered functions.
What do they look like?
By definition.
So that
You're going to
line-
see it.
So that
in just a
line is
second.
a one-to-one function?
Yep,
But
this
the
line is a one-to-one
quadratic
function because the line,
But the quadratic isn't as the y as two y's?
yes. Yes, okay, we'll get there, yes. Okay, so right here, is this set of points a one-to-one? Is it a function? Each x only has a one y, right? But is it one-to-one? Yeah, all of our y's only have one x. Look, do you see 8 twice anywhere?
No.
No, so we're good. Do you see 4 twice? No, 2, 3, 6. Do you see how all the y's are different? We're good then. Moving on. So, everybody, the vertical line test is this. If it only touches your pencil in one place, it's considered a function. What the horizontal line test tells us is if it is one-to-one. So, does it only touch your pencil once on the horizon? Yeah. Everywhere. Yeah. So, this is a one-to-one function. Now, is this considered a function? Does it pass the vertical line test? Yes, it does, right? But does it pass the horizontal? No, there it's touching twice, so this would just be a non-one-to-one function. It's not one-to-one.
It's called a non-one-to-one?
It's just not one-to-one. Yeah.
So
Yes.
a function is when, just a function in general is when each x only has one y, but a one-to-one,
Yeah, one-to-one.
it works opposite also.
Right.
So there's only one y for every x and only one x for every y.
Yes. Uh-huh.
Got it.
One-to-one just means the backwards idea of that. Okay, so with this one, pass the vertical line test.
Yes.
Yes. Would it pass the horizontal?
Yep.
Yep, so it is one-to-one and it is also considered a function. This one would pass the vertical line test, wouldn't it?
Yep.
But would it pass the horizontal? No, so it is not one-to-one. This function is not one-to-one. Okay, awesome. All right, so now here's how we find inverse of functions and relations. So if we're given a set of x, y points, to find the inverse, all you got to do is switch x and y. It's that simple. So what would be the inverse point for 2, 3? 3, 2. Okay, good. What would be the input? Negative 5, 3 is the inverse, and 2, 4. Does everybody see? Black is the original, pink is inverse. All good? Easy stuff. Now look at the original function here. If we look at the original function, if I ask you what the domain is, remember domain for all functions means what are the x values? So what would you say? 2, 3, 4. Isn't that the domain of the original function, the black function? What would our range be?
3, -5, 2.
3, -5, 2. Correct. Now look, we switched x and y, so it makes sense here, looking at the domain of the inverse, sorry, moving this out of the way. So looking at the inverse function, isn't our domain 3, -5, and 2?
Yeah.
And then our range would be 2, 3, and 4.
Yeah.
Now what do you notice?
The opposite.
Yeah, this one's domain will be the inverse's range. This one's range will be the inverse's domain, right? That will always happen for inverses. If you know the domain and range for the original, you also know the domain and range for the inverse, because you just swap them. Okay, so right here, if I'm asking you, here's the original relation, what would the inverse look like?
Cat, boy, dog.
Cats to boy, correct?
Yeah.
And then it would be
Dog, dog.
dogs to girl. Okay, good. So now right here, if I said, what's your domain, you would say,
Boy. Cat. Well,
Boys
there's
to
it boy.
dog.
Wait.
isn't domain input.
Yeah, so boy, girl.
Boy, girl. So we automatically know this one's range is boy, girl. Correct, everyone?
Yeah.
Then my range here was cats, dogs. So this one's domain is cats, dogs. Okay. If I give you a picture of a graph and I say graph the inverse, there are many ways to do it. The easiest way is to write out the points and then swap them. So give me some of the original points in order from left to right.
-4, -2. -1, 0, and 4, 2. Wait.
Okay, so our inverse points would be -2, -4, -1, -3, 0, -1, right? Just making sure. 2, 4. Okay, awesome. So now let's plot those points. This point becomes this point. So you'd say, okay, -2, -1, 2, 3, 4. -1, -1, 2, 3. 0, -1. And over 2 up 1, 2, 3, 4. Now if I connected them, doesn't it look like that? Now what I want you to notice, this is important to note. If this is a reflection over the y equals x axis, y equals x. So how do I graph y equals x? This is a reflection over y equals x. Y equals mx plus b. How do we graph lines? Y-intercept slope, right? So if I said that this is a reflection over y equals x, wouldn't our y-intercept be 0 of the yellow line? Our slope's up 1 over 1, up 1 over 1. Do you guys see how I drew it in? Okay, so these are a reflection over y equals x. What that means is, look, this maps evenly across to that. Do you see? This maps evenly across to that. This and this equidistant, this and this equidistant. So it makes sense that those are reflected. Okay, so if I said to you, what's the domain, you would say -4, -3, -1, and 4. Then you would automatically be able to go down and do the range is that as well.
Yeah.
And then this one's range is -2, -1, 0, 2. So your domain is -2, -1, 0, 2. Oops, I didn't mean to put parentheses.
Well,
Okay, so on the test, I might ask you, I might give you a picture like this, and I might say, are these inverses of each other? And so if it is a reflection over y equals x, you'd say yes, right? Or you would just write down the xy points and flop them and see if they all match up. Okay.
Looks like the
So writing the inverse of an equation, these are the steps you take. First, switch x and y. That's your first step when doing it of an equation, which makes sense. That's what we do, is switch x and y on our points. Then second, we got to use correct algebra in the correct order to skip y back alone. We always like it y equals. So piece by piece, we'll get y alone. We'll solve for y. And then we just have to write it in the correct notation. So this is how we write that it's an inverse. We just have this little like -1. The -1 doesn't actually do anything. That's just saying f inverse of x. So correct notation. So let's do our first step. F of x is the same thing as y. First step is switch x and y. So x is equal to 2y minus 3 over 5.
multiply by 5.
Good. We got to undo the divide by 5. So we times by 5 to both sides. Then you have 5x equals 2y minus 3. So then you'd set it at 3. So you have 5x plus 3 equals 2y. Divide by 2. And then we'd write it in the correct format. F inverse of x is equal to, this format and this format should look the same. So you would say 5x plus 3 over 2. However, would it be appropriate if this was a multiple choice test to see this answer, 5/2 x plus 3/2? Yeah, as long as you divide both of them by 2, it's okay to split up, right, everybody? Okay, awesome. Another one. Let's do another one. This one you need to take note of because something interesting happens here. We need to take into consideration something interesting. So it says find the inverse and state the domain and range of both the original function and the inverse. So the first thing we do is switch x and y. So we have x is equal to the square root of y minus 4. Then what would we do first? Add 4. So we have x plus 4 equals the square root of y. Then we would square it. We need parentheses, square it. Okay. So our f inverse of x is equal to x plus 4 squared. Now here's what we actually have to take into consideration now that we're in a more advanced math class. Is that truly our inverse? Meaning, let me show you something. We know how to graph this. That's what we just learned in the last unit. It's a square root function shifted down 1, 2, 3, 4 units, correct? And then it looks something like this, a rough sketch here, correct? Now let me graph this one. We know that's a shift of left 4, so left 1, 2, 3, 4. There's negative 4. But if I were to graph this, wouldn't my quadratic have both sides? Look, are those inverses of each other? No, there's too much information. It's not x squared. It's not x plus 4 squared. It's not the whole thing, correct? You see how this doesn't have the bottom half? Yeah. Well, then this is too much information. So which one would it actually be? It would be the right side. Now here's how you can know for sure. Let's go to the original. So we're going to actually need to scribble out this side. Now here's how you can actually know that for sure. Here's how. Go to the original function and find the domain and range. So what's the domain of this? Yep, 0 to infinity, isn't it? Yeah. And our range is? Negative 4 to infinity. Well, that gives us the domain of this quadratic, doesn't it? It's the range of that. So our domain is actually from negative 4 to infinity of this one. So now we actually know it's this half because isn't that saying our domain is x values greater than or equal to negative 4? So we're keeping the x values greater than or equal to negative 4. So that would be this side we keep. So you'd say, this is our inverse, but only for x values greater than or equal to negative 4. Yeah. So just take some extra thinking. Now that only happens, we only run into that problem if we start with the square root because our inverse will be a square, with a parabola, and then we only can have the one side. So you would just find the domain and range, then you need this one's domain, because then you'll say it's only the quadratic on this interval for x. That's what that's what the inverse is. Okay, awesome. Let's do another one. No, I haven't, and I undownloaded it and everything and re-downloaded it. Okay, so switch x and y. So we have x is equal to 2y minus 3 squared plus 4. Then what? So we have x minus 4 is equal to 2, and then y minus 3 squared. Divide by 2, divide by 2. So we have x minus 4 over 2. We wouldn't just divide those out, would we? Yep. Y minus 3 squared, then what? Square root. When solving and taking a square root, we can't forget to put a plus or minus in front. That's just how, when solving with square roots, what we get. So now we have this. Y minus 3 is equal to plus and minus the square root of x minus 4 over 2. And then last step. Add 3 to both sides. So f inverse of x was plus or minus the square root of x minus 4 over 2, and then our plus 3 out here, right? Now that makes sense. That's all good to go. Here's why. Let's think about this. If we graph our quadratic, that would be right 3 up 4 units. Something like that, correct? And then we now have this square root function, which would be a reflection over y equals x. So look, if I reflect it, it'll look something like, I don't know exactly where it would match up, but something like that. Correct, everybody?
Yeah.
So do you see how it makes sense that we need the plus or minus? Because here's the plus, and here's the minus part. Yeah. Yeah.
If we could simplify what was under the radical value.
So if this would be appropriately correct, 1/2 x minus 2 plus 3. You see how I split it up?
Yeah.
But it's not necessary necessarily.
But if we could simplify it, like,
Well, if you have a variable, how are you going to simplify it? Does that make sense? Because it'll be a statement, not like a... Yeah, good question. Okay. And we would never square root across a subtraction sign, right? Okay, awesome. Okay, I think we get the picture with that easy of one. Okay, you do this one by yourself. Make sure you're good with inverses. F inverse of x equals cube root of x minus 4. Very easy. Good. We don't need plus or minus with odd roots, right? Only even roots. Okay, sweet. Go again. Find the inverse again. Answer. What is it? Anyone else get a different answer? Are we good? Need to go through it? No? Okay. Awesome. Okay. Now, do you want to do one more so you can see if you can restrict it correctly? This is the one that has a restriction that we just talked about.
Wait, what's the restriction?
Yeah, I would recommend it. Yes. At least what's the equation of the inverse?
Oh, x squared plus 2.
X squared plus 2, and then you'd say, okay, but it's not the full quadratic. So I would go to the original function. How do we shift that? Right 2, square root looks like that. Domain is 2 to infinity, but that's not important to us, all right? It's more our range.
Oh, it's greater than or equal to 0.
0 to infinity, so that's going to be this one's domain, 0 to infinity. So then it's going to be x values that are greater than or equal to 0. That's our inverse.
I didn't guess that time.
Right, you did not.
Yeah, but if I...
Okay. So, let's do another one like this. Okay, so I mean we haven't done one like this yet. So, switching x and y. A lot of people kind of get thrown off with something like this. 3 over y minus 2 plus 5. What would be the first step? So we have x minus 5 is equal to 3 over y minus 2. Now people will get lost. They'll say, well, I don't know what to do now. I'm trying to solve for y. But it's in the denominator, isn't it? So we need to bring it up into our numerator somehow.
Multiply by 1/3.
On both sides, times the y minus.
Yep, times both sides by y. What does division? Multiplication. So that's grouped, isn't it? So we're going to multiply by y minus 2. I need parentheses. Oh, I better put parentheses here too. Y minus 2. So now on this side I have this. Y minus 2 times x minus 5 equals 3, correct? Now think about what you're doing next. If you start distributing, that would not be wise, because then you would have multiple y's, wouldn't you? So literally get y alone. Divide by x minus 5.
And then you add 2.
And then add 2. So f inverse of x is equal to 3 over x minus 5 plus 2. So you just got to keep your goal in mind as you're going. I'm trying to get y alone, so it makes sense to undo this times by x minus 5. Get the division. Okay, this one, write it down. There are going to be times when you have two or more of the same variable. So you're going to tackle it like this. Now, if you were in my class last year, you've learned how to do this. Other teachers' classes, most likely a no. So switching x and y is still our first step. So x is equal to 2y over y minus 3. Now what should be flashing red signals at you, like red flags, is we have two y's here. When that happens, then we got to tackle it a little bit differently. Now first of all, we don't want the y's in the denominators. That's an absolute must fix. So what should we multiply both sides by? Multiply both sides by y minus 3. So now we have this. Y minus 3 times x equals 2y. Now here's the thing. In the last problem, we were solving for y, and we got to this point, and we were able to, since there was only one y, we were able to just solve, right? Yeah. But in this one, there's two y's, so you have to distribute. So now we have xy minus 3x equals 2y. So now notice we have two y's here. We have more than one y. What you're going to do is get everything with a y to one side of the equation and anything that doesn't have a y to the other side. Now think about y. Then we could pull out a y, couldn't we? And then we only have one.
No, that you just minus xy.
Yep, so get everything with a y on one side. So subtract xy. So we have negative 3x equals 2y minus xy. And now everything on this side has a y, doesn't it? So now we can pull out a y.
Oh, I get it.
So then now we only have one y, because doesn't the y divide out?
Yeah, these two is
So then we have 2 minus x equals negative 3x, like this. Yep, divide by 2 minus x.
We're looking at the two x's.
Yep, just like we did here, you know?
Oh, yeah.
Now understand, okay, I know you're advanced enough thinkers enough to see, okay, let's say you left your answer like that. When you check this back of the book or the side of the book, and you did not see the exact same answer, how could they possibly be rewriting this? Negative 3x and then
Over 3.
negative x plus 2, correct?
Oh, yeah.
But then that's not considered appropriate, so we would have negative 3x, negative 1x minus 2, wouldn't we? So then wouldn't the negatives divide out? This answer is the exact same answer as this, it's just the negatives are getting taken care of. Because writing things in standard form is usually better. Okay, try this one by yourself.
How many lessons?
1.
Oh,
Oh,
yeah.
it's 2. Oh, and then negative 1 minus x underneath that. Minus x equals y. So I did something wrong there.
That's what I got. I just put the x in.
Yeah, I think that looks good, except I would just now write it in a prettier format. Maybe put the x first, you know? So that would be negative x minus 1, wouldn't it?
Yeah.
And then it would just be considered prettier to go, they don't leave negatives on the front, right?
Yeah.
It's okay if it was just x minus 1. So then we'd pull out a negative 1 and then x plus 1, right? Now once again, what the book would do is take the negative 1 out in front.
Okay.
So x plus 2, negative in front, x plus 1. Because remember, the
So-
negative can be on top or bottom, right? Or out in front, say all good, right? Remember, we can reorder.
You grade our test?
Yes, so I mean,
I'd still get it right if I put the way I put it.
yeah, probably, most likely. If anything, you'd get docked a smidge. It's probably fine though. Okay, is everybody good with those? We're almost actually done with the lesson. This is the last thing here. So it says verify the following functions are inverses. Now, how would you do it if I just said
Find
this?
the inverse of one of them.
Yeah, just use one and find the inverse of it and compare it. Yes. Now here's the catch though. Okay, on the test they might say, in more specific terms, verify if the following functions are inverses of each other using function composition. So here's the rule. If we just learned function composition, if that would feel random if we didn't use it in some way. So here's how. It is true that if you take and do f of g of x, so that would be substituting that in, right? So f o g of x and g o f of x, if you do both of those, you should simplify it and they should both simplify down to be x, specifically x. So where are we getting x? Y equals x, isn't that the reflection it's over? So it makes sense it's connected. So they should both simplify to be x. So you would do both. So you'd also take this and plug it in right there. It's just algebra after that. So let's do the first one. Look at the red one. So we have 2 over, instead of an x, don't I have 2 over x minus 4? Then I have plus 4, don't I? Does everybody see? The algebra comes out pretty nicely if you can do algebra correctly. So on top I have a 2, and on bottom, don't I have 2 over x? Because those become 0, don't they? Then everyone, a lot of people cannot flip and multiply correctly. If you can't, then write it like this. That's 2 over 1 on top divided by 2 over x, isn't it? Dividing fractions is easy as pie. Flip the second and multiply. So is it x? Yes. But now we got to do it the other way, because just because it works one way doesn't mean it's going to work the other way. So let's do it the other way. So you'd say, okay, let's plug. So looking at orange, so we have a 2. No. Yeah. What? Did I do the wrong one?
Yeah.
I did orange first, didn't I?
Yeah.
Yeah, I was writing in orange. Good point. I'll write in red now. So now we're doing the red. So take red and plug it in there. So we have a 2, and instead of that x, we have all of that. 2 over x plus 4 like that? Then minus 4. What should I do first? We can't combine that with that, right? That's in the denominator. Dividing fraction.
Easiest part.
Flip and multiply. So isn't this 2 over 1? So then we have this 2 over 1 times x plus 4 over 2 minus 4, don't we? 2's divide out.
Oh, it's X.
X plus 4 minus 4 is x. So that's how you show it with function composition. Now let's say you're like, did I do my algebra? Let's say you got no. And then you could say, well, did I do my algebra right? Or did I mess up on my algebra? Take one, find the inverse, and if it's yes, then you've messed up somewhere. You guys see how to use common sense to kind of cheat around it. Okay, awesome. Okay, so now let's go.
How do you teach all day?
Okay, let's read a story problem and see that it is just a function composition. This is number 89 on the homework. It says, an oil tanker hits a rock that rips a hole in the hull of the ship. Oil leaking from the ship forms a circular region around the ship, which makes sense, guys. Think about it. If all of a sudden there's oil leaking, it's now going to create some sort of circle around that ship. It says if the radius of the ship, is a function of r radius in t hours, the formula for radius is this. R of t is equal to 20t. So that stands for radius, doesn't it? 20 times. Now that's meaning, like, they mean the radius of the ship, meaning the radius of the oil from the ship. So think about it, that makes sense. Over time, won't the radius get larger and larger? Okay, awesome. So now it says express the area of the circular region contaminated with oil as a function of time. So it wants area as a function of time. If that's radius, what can I replace the radius with? 20t. So that's the same thing as this, pi times 20t squared, right? Radius. And then that's just a function composition. So wouldn't that be, look, if you squared both of those, that would be 400, 20 squared, and then we have a pi, and then a t squared, right? There's the area function as a function of time. And it says, what will the area be after 3 hours? So you just plug in 3 right here and calculate it. So just because it's a story problem doesn't make it harder. Okay, that's the end of the lesson. The rest of the time is yours.